Hello, all of the English students out there connected to the #1 website in the universe for learning a second language. Of course, I'm talking about verbling.com, because at verbling.com we have an English class waiting for you 24 hours a day, 7 days a week. What an amazing opportunity for you to connect and develop and improve your English. Fantastic. So, welcome. What I would like to do is to ask the students to please download and open document AA3. I have posted the direct link to the document in the Verbling chat box. This hour we are going to be talking about science, some basic science information. We are going to be reading about and watching short video clips about the currents that move in the ocean. So ocean currents that move water from the south to the north and back again. And so I wanted to share with everyone also the two tools that we are going to be using this hour. Could everyone please use the microphone button to turn on and turn off their microphone? This will keep our classroom quiet and eliminate all the noise from the background. You can also turn on and off your microphone by clicking on the menu below your video image. We are also going to be watching several YouTube videos. Now, you have two options. You can click on the left-hand side of your screen to turn on the YouTube application, or you will be able to click on the YouTube link that I have put in the Verbling chat box. In the future, I will put the YouTube links in the Verbling chat box. All right, and so what I would like to do is to start the class right away. So I would like to start the class right away, to start the class now, because we have several videos and several pieces of text to read about this subject. And as we repeat the information and review the information, I think everyone will understand more and more. All right, and so let's open up the document here, and I'm going to put the document on the share screen. I have some images from Google Image, and so I would like Abodai, Ashaur, Abodai. Abodi, okay. Thank you. Welcome. Where are you connecting from?
Jordan.
Good. And so could you please, and now you have an echo in the background, and so we ask that students use headphones, or headphones are important, and also you may need to close the verbling.com window. So really, people only need to have the Google Hangout window open on their browser. If you can go to the verbling.com window, you can close it, or you can click and pause the video on that. All right. And so, Abodi, are you ready? Now, you need to turn on your microphone. Okay, I'm sorry, we can't hear you right now, Abodi. I will come back to you. And so, Ahmad, are you there? Hello, Ahmad, Tikhan? Okay, I'm sorry, we cannot hear you either. And so, Anne. Hello, Anne.
Hello, Geoff.
Yes, please tell us where you are connecting from.
I'm from in Ukraine, and we are sunny day.
Okay, great news. And so, could you please describe what you see in the image here?
This is maps,
Yes, it is a map.
and there is America, ocean,
Yes, okay.
White Ocean is
Yes.
Australia.
Okay, sure. It shows all of the continents and the oceans. And what do you understand by the different colors that you see in the map?
In center is red. It's
What do you
Equator.
think? Yeah, the equator. Good.
Equator, and there are I don't know.
And what do you think it symbolizes? The colors.
Temperature.
Yes. Okay, great. And so we are going to be talking about this. We are talking about currents and the movements of the oceans. And generally, this is thought of as the way that heat moves from the equator to the poles. Okay, thank you, Anne. Welcome. And I would like to talk to Ahmad. Hello, Ahmad.
Hello.
Yes, please tell us where you are connecting from.
From Saudi Arabia.
Okay, welcome. And I'm going to move down to the next image. What do you see here in this image?
I see. I don't know.
It is a map.
Yeah.
And showing, what does it show?
Right. Great.
Okay. And so what I'm going to...
I don't know.
Yeah, okay. No, that's fine. Thank you. Thank you, Ahmad. I will come back to you. And I would like to say hello to Abodi. And I need Mon. Are you there, Camila?
Hey there.
Yes. Could you please keep your microphone turned off for us?
Okay, great.
Yes. Everyone needs to keep their microphone turned off while they're waiting to speak. That eliminates a lot of noise from the classroom.
It's okay?
No, please turn off your microphone. Click on the microphone to turn it off. Thank you. And so, Abodi, are you there?
Okay, yeah.
Could you please explain what you see in this image?
I see ocean few currents
Yes.
Maybe speak about weather depends more of solar energy.
Yes, absolutely. The ocean currents have a lot to do with weather. That's very important.
Maybe there is mean of hotel from Atlas.
Yeah. And Bobby, we do thank you for having your video on, but your sound quality is not very good. It may be better if you turn off your video. Your sound may be better. Thank you. Thank you. I will be back soon. And Hamid, hello.
Hello, how are you, Geoff?
I'm fine. And so what I would ask is everyone else, I'm going to speak to Hamid, and so could everyone else please keep their microphones turned off now. Hamid, what do you see here?
I see directions of current ocean currents.
Mm-hmm.
For example, from Asia to South America, like this.
Okay.
And
yeah, go ahead, please.
I see which current affects cold or
yes,
warm effects.
So there are cold water currents and warm water currents.
Yes, definitely.
Okay, great. And this is called the global conveyor belt. This is the name for this. A global conveyor belt. I have a picture of a conveyor belt on the document if people are not sure of what that is. Great, thank you. Welcome. And Hanu, are you there?
Yes.
Could you please explain what you see in this image?
Maybe Earth?
Yes, this is the Earth, a map of the Earth, yes.
And the green? Something green?
So
nature.
The green is what? Sorry?
Nature? Maybe nature?
Well, nature, I think
yes.
Green symbolizes the land.
Mm-hmm.
And the continents.
Yes.
And what do the red and blue arrows symbolize?
Maybe water?
Yes.
Warm water.
Good. So the warm water moves on the surface.
Mm-hmm.
Where does the cold water move?
Under?
Yeah, under the surface.
Yes.
In the deep ocean. Okay. So this is the idea of the major or big ocean currents. Okay, thank you. Great. Good work. And Ismail, hello.
Okay.
Hello, Geoff. How are you?
I'm fine, thank you. Welcome to the class.
Thank you, Geoff.
You are connected from Turkey.
Yes.
Could you read this first paragraph for us, please? And could everyone else please keep their microphones turned off? Go ahead, please, Ismail.
The ocean is in constant motion. You can see this for yourself when you watch waves crash onto shore. If you go swimming, you may even feel an ocean current pulling you along. Surface currents, such as the Gulf Stream, move water across the globe like mighty rivers. Surface currents are powered by the Earth's various wind patterns.
Okay, great. And so we're talking about the movement of the ocean. It's constantly moving, all of the ocean waters. Okay, all around the world, the water of the ocean is moving. Great.
May I ask a question,
Yes,
please?
yes. Thank you for asking questions.
Great. What is the difference between current and streams? When I have to use streams and when I have to use current?
A stream really is a small river.
Okay.
So this is how we usually use the word a stream, is a small river. Currents are the movements of the water in the ocean, but it's like they are moving like a river, but within the ocean. Yeah.
Okay.
Good.
So the proper word here for streams in the ocean is current and not streams.
Yes, exactly.
Gulf Stream is just the name for it.
Correct. This is what it's called. And if we go back, I believe that this red arrow going north of warm water is called the Gulf Stream. Yeah. Maybe this one coming from the Gulf of Mexico, the Gulf Stream. But I think there is also a Gulf Stream in the air. So moving air or water is sometimes called a stream. Stream is also a verb. To stream is to move.
Okay. There are jet stream in the high, high level of air, Geoff.
Yes. Okay, that was the word that I was
strong wind.
Yeah, the jet stream. Exactly. Yes. So that is air moving. The jet stream. Good. Thank you. I was going to ask you, Ismail. All right. And so, Mont, could you please tell us where you are connecting from?
I'm from Russia.
Okay, great. Welcome. And could you please read this for us?
Of course. The ocean also has deep underwater currents. They are more massive but move more slowly than surface currents. Underwater currents mix the ocean's water on a global scale, a process known as
Haline, I believe.
Haline, yes. Circulation of the ocean conveyor belt drives these deep underwater currents.
Okay, so first of all, this word here is a very scientific word, and please don't focus on this word. It's not a common word. It's a very technical, scientific word. So please don't focus on it. It's not important. Okay? But we're talking about conveyor belts. People understand what conveyor belts are?
Yeah.
Okay, so these currents are described as conveyor belts. They are massive. They are huge, extremely big, but they move water slowly. They are not like the small surface currents that are caused by, let's say, the wind, mostly. Okay? And so it mixes the oceans on a global scale, mixing all of the ocean water in the world, but slowly. So this is what we're talking about. And if I could go to Nina, and I'm sorry, Abodi?
Yeah.
I'm sorry, you need to keep your microphone turned off, please.
Okay.
Thank you. Thank you. And so, Nina, go ahead, please.
To read this paragraph?
Please.
Okay. Mass flows of water or currents are essential to understanding how heat energy moves between the Earth's water body, land masses, and atmosphere. The ocean covers 71% of the planet and holds 97% of its water, making the ocean a key factor in the storage and transfer of heat energy across the globe.
Okay, great. And could I ask any student, and nice job with your pronunciation, Nina.
Thank you.
Could someone please repeat the information that's here? I think this is important.
Information is clear. The water is very important source for energy.
Yes, okay. It stores a lot of the solar energy, the heat energy that comes from the sun. And some other comments? Yes, Hamid?
Our planet's third quarter is covering with water.
Yes, so almost 3/4 of our planet is covered with water. Almost, yeah. Good.
Geoff,
Yes? Ismail?
the oceans are emitting the heat energy which comes from sun, and they are reflecting some of them onto the air, and
Yes.
uh,
Transferring.
and carrying the heat energy with the ocean current from north to south, or
Yes.
circulatory way. They are
Yes.
changing the climate. They are
Yes.
smoothing the world climate.
Okay, yeah, they are transferring this heat from warm places to cold places. So everyone is doing a great job. This is the participation that we need. So great job, everybody. Let's keep getting short comments from everybody just about the information, that you understand the information. I would like to go back to the first photograph, or, you know, and so what is the situation here?
I think it describes which field is intense and which field is normal for their location, current, ocean current.
Well, okay, Hamid. Sorry, I understood what you meant, but can people try to use just some simple words? What's happening here? This is science, but I want to help people express these ideas in simple English. Could someone else make a comment? What does this
Yes,
map
sir.
show? Yeah?
I
Ismail? Or yes? Just one idea, please, Ismail?
Me,
It's
Geoff?
kind of a
Yes.
map of temperature.
Okay, yes. And so go ahead, Nina. What does this information say though in normal
Okay,
English? Yeah.
I think the color signs the temperature on the map, and the highest the temperature is, the warmer is the color. I mean,
Yes. Okay.
the
And
red,
sorry, where is this warm water?
at the oh, I forgot.
Yeah.
I
Who
can-
remembers? Sorry. Who remembers the
In the
middle of the
middle,
earth?
in the middle of the map.
Yes. Someone, please.
In the
I can-
equator zone.
Equator.
Yeah.
In the equator zone.
Yeah.
Okay, but hold
Yeah.
on the equator, that
On
is
the
the
equator.
line or equatorial zone. All right. And so, as we talked about, the currents will move this heat from the warm equator or equatorial zone to the colder poles. So not just north and south, but towards the North Pole and towards the South Pole. Okay, and I put the verb to even out the ocean's temperature. Do people understand that phrasal verb? To even out?
I can.
Even you do you mean in Equator?
Sorry, I'm talking about the concept of evening out the temperature. Anne, did you want to say something?
Yes.
They are
Sun-
balancing.
Sorry, I'm going to talk to Anne here. Go ahead, Anne.
Sun temperature water in Equator very.
It's very warm near
Warm.
the equator. Right. And what does it mean to even out?
And
It's kind of diffusion.
Yes, to
Balancing.
diffuse, to balance. Good.
Yes.
Okay, good. To create a mixture of the hot water and the cold water. So that's the idea, to even it out, to have a balance. Okay, great. Good work. And so just if I could ask everyone to please turn off their microphones, and I'm going to go to, sorry, it's Nina. Could you read the next paragraph for us?
Okay, may I see?
Sorry, I think this is it here. Yeah, good. Could you read this for us, please?
From the movement.
The movement, thank you.
Okay. The movement of this heat through local and global ocean currents affects the regulation of local weather conditions and temperature extremes, stabilization of global climate patterns, so cycling of the gases, and delivery of nutrients and larvae to marine ecosystems.
Yeah, and
what does it mean, larva?
Ecosystems. Yeah.
Ecosystems.
Could someone describe what larvae are?
Small eggs of fish.
Good. Now,
planktons.
That's close. Not eggs exactly, but
the exact small creature of the big sea creature or fish.
okay. Can someone else try to? And again, people are practicing their English by repeating the same information. Go ahead, please.
Still, I couldn't understand the word
Yeah,
larva.
no, it's okay. Larva. So what are larvae? They're not exactly eggs. Although the ocean current will move eggs. What are
Geoff,
larvae? Yes?
Geoff, is it about the frog?
I'm sorry?
Frog, F-R-O-G.
Frog. Well, yeah, frogs have...
Frogs.
They have a larval... I don't think frogs...
Evolutions of frog.
They have to.
No, but I don't think tadpoles are larvae.
Small jumping animal.
Animal forms.
No, but Amoli? Sorry,
Small jumping
Amoli?
animal. Small jumping
Simple
animal.
animals form.
Well, okay, but frogs are small jumping animals, but what are larvae? And think of mosquitoes.
Maybe live in land and in water.
In water, good. And think of
and
mosquitoes.
Maybe it's a crab.
Okay, all right. So what my understanding is, if you think of mosquitoes, okay, they come and bite you. All right? Mosquitoes begin as eggs. The eggs are in water.
Yeah.
The eggs hatch. The eggs open, they hatch, and the larvae live in water. It's a different stage of life. Then the larvae turn into the adult mosquitoes. So it's a baby form of the animals, but a different form of the animals. Okay, so let's move on. That would be a word from Latin. So many languages would use the same word, larva, I think.
And nutrients?
Nutrients. What is nutrients in simple words?
The food?
Yes.
Okay.
Yeah. Yeah. Food.
And develop nutrients in larvae.
Okay. Because this is important as well. Not only moving temperature, not only moving the heat, but what else is moved by these currents?
Okay.
Stabilization
So currents has...
So, sorry, Hamid?
Stabilization of global climate.
Climate? Okay, but what I'm saying is, what my question is, what are moved by these currents? So they move heat. What else?
Affects the regulation of local weather.
Okay, sorry, Hamid. I'm asking a specific question here. The Earth's currents, the ocean currents move what? What do they move? So they redistribute heat. Okay, what else do they move?
They move food.
They move
nutrients.
Food or nutrients, yes. What else?
The legs of fishes, maybe?
So eggs and larvae of different species. Good. And there's one more thing that they move.
Do we have it on the text?
Yes, yes, it's all in the text.
Cycling of gases.
Gases. Like what? Like what is an important gas?
In the water?
Oxygen.
Yes, oxygen. Okay. So all of these things are moved on a global scale. This is the content of the text. So
hello?
Yes, hello.
Can you hear me?
Yes, we can. Yes.
Very good.
Okay. And so we're talking about these global ocean currents. They are very important. They move heat, they move gases, they move nutrients, and they move animals. They move eggs and larvae all over the world. Yeah, maybe animals travel in the currents as well. But that's not in the, it doesn't say that though. Okay, it just talks about larvae. All right, so this is very important. This movement is very important. Okay, great. And so I would like to go to, I'd like to go back to Abodi, and could everyone else please turn off their microphones, please? We need students to please turn on their microphones when they're speaking and turn off their microphones when they're not. Go ahead, Abodi.
Okay, I read.
Yes, it would take.
It would take a single water molecule approximately 1,000 years to complete one full cycle of the global conveyor belt. In that time, the water molecule would travel through the water of all the major ocean basins: Pacific, Atlantic, Indian, Southern, and Arctic.
Okay, and so if I can go very quickly to the earlier photograph, I think this entire pattern here is the global conveyor belt, the current conveyor belt. So they're saying that to go from North America all the way around the world and back again would take 1,000 years. So it's slow, but it moves all of the waters of the ocean. Okay, and so what I would like to do now is to just turn off the screen share, and I would like to play a YouTube video now. And what we're going to do is just continue reading and listening to the same information. But are there any comments from people at this point? Would someone like to make a short comment? Okay, so I have put the YouTube video link in the chat box. So you can click on this link and watch the short video in another window on your browser. And I am also going to click on the YouTube application and play the video there. If people are watching the class, you need to click on the YouTube video link. You will not be able to see the video playing. You will need to watch the video in another window.
I want to.
So just please, everyone has control over the video, so please try not to click on the video because you will make it go back, you will stop it, or make it play again. But I think we've finished with the information in the current, in the video, the information about currents. So can someone make some simple comments about the information in the video?
It was
I have one.
Yes, and sorry, I would like to try and talk to Ahmad. Hello, Ahmad?
He's not connected to the thing.
Yeah, well, okay, no, that's great, thank you. And so, Hamid, you had a comment?
Yes, for example, it is interesting thing. I mean, for example, northern hemisphere current is clock turn.
We say clockwise.
Clockwise, but for southern hemisphere is anti-clock.
Good, and personally, I'm Canadian, I say counterclockwise.
Oh, counterclock is anti-clock?
Yes, but I never say that though. So counterclockwise is what I say.
Counterclockwise. Okay.
Okay, but you understand the concept, okay?
Yes.
What causes that? What causes the rotation of the currents?
The rotation of the current causes the icebergs.
Oh, sorry. What causes the rotation of the currents?
The source of them.
There are many reasons of the currents, Geoff.
Okay, but sorry, in the northern hemisphere, the currents rotate clockwise. I don't know if this looks correct on the video. In the southern part of the world, the southern hemisphere, they rotate the other way, counterclockwise. And what causes that?
Because the magnetic...
Sorry, not the magnetic field.
Maybe equator.
Sorry?
The rotation of the world, maybe.
Okay, Nina, did you have an idea?
The move of the year, the movement
of the Earth, and Ismail used rotation.
The rotation of the Earth.
Okay, so that's what causes that.
And Geoff, can we say form of Earth? It causes.
It's caused by the. Is that
form
what you
of form? For example, Earth form is
continent formation.
Oh, the shape of the Earth?
Yes,
the shape of continents.
Okay. Yes. Now, but in general, the ocean currents move because of the shape of the continents. But the rotation clockwise and counterclockwise, I think that is 100% caused by the rotation of the Earth. Yeah, but the movement of these ocean currents are affected by many things. Okay, great. And so what I would like to do is to show another video. And this time, the video is going to focus on the movement of oxygen, the cycling or movement of oxygen. Let's watch this. First, I'm going to put it in the chat box. So for those of you who are watching the class, you can watch the YouTube video in a different window. And for those of you who are part of the class, if it works for you, you can watch the video with the YouTube application. And if everyone could please keep their microphones muted, please. So again, if people can try not to click on the video, please. Please do not click on the video. Did people understand a little bit of the video?
Yes, sir.
I understood. It comes from deep to bottom.
From, sorry?
From deep to surface.
Oh, okay. Well, I think in terms of oxygen, how does the oxygen move?
I think it move because the difference between the temperature on the surface, it is warm water, and the warm water going down, right?
Sorry, no, but you're very close. It does the current, the great conveyor belt, these huge ocean currents are driven. They receive their energy. They are caused by changes in temperature and density. But I wanted to ask about the oxygen. How is oxygen moved through the ocean? Where does the oxygen start?
Deep side. From deep side.
Sorry, no, the oxygen does not start in the deep.
No, from the waves?
Yeah, at the surface.
Yeah, at the surface, yeah.
Okay, and I put in the Verbling chat box. In the video, it talks about that oxygen gets mixed into the water with waves and tides, all of the movement on the surface. And then how does the oxygen dissolved in the water at the surface get to the deep ocean?
The oxygens are transported from south to the North Pole, and it gets colder and colder, Geoff.
Okay, but sorry, no, but the oxygen is not transported from North to South Pole. Not really.
They are transported via conveyor belt.
Well, by these huge ocean currents, right? Yes. Which we call the global conveyor belt. Okay.
When it comes to the north cool water, it gets dense and turn back to the into the deep of oceans.
Into the deep ocean. Okay. Let's do some reading. Let's go back and do some reading. And so, Anne, are you there?
Yes, I'm
Hi,
there.
Anne. I'm going to bring up the document on the share screen. And let's do some more reading before we watch another video. Could you read this short paragraph for us, please?
The volume of water, yes?
Please, thank you.
The volume of water transported by the global conveyor belt is equal to 100 Amazon rivers, or 16 times the flow of all the world's rivers combined. Combined.
Okay, and so what is the information here? Anybody can answer, but go ahead, please, Anne. Sorry, this is an image of the global conveyor belt. This is this huge ocean current.
The water go to the Amazon River.
Sorry, no, Anne. Sorry, they're comparing it to the Amazon River, but yes.
The volume of water. Yeah, it equal the Amazon River, 100 times the Amazon River.
Okay, and so do you see this current, this global current? All right, and so they're saying that it's slow moving, but it's huge. It's amazingly big, and it is how is it 100 times?
Amazon River.
Yeah, okay.
Yes,
so it's very slow moving, but it's very big. Or compared to all the rivers combined, what is it compared to all the rivers combined? Does anybody have the document there?
It is 16 times more.
Yes. Okay, and sorry, I need to speak to this Adnan, are you there?
Yeah, I'm here.
I'm sorry, you need to please keep your microphone turned off for us, please. Adnan, hello?
Yeah, I did.
Oh, okay, thank you. And so, yeah, so the amount of water, Ismail said, it carries a huge amount of water. So, right, it's an amazing amount of water. Okay.
Very big, but very slow.
Yes, and this image will show you what happens to the oxygen. How is oxygen moved through the ocean?
But how oxygen mixed with the water?
Where?
No, I mean how.
Sorry. Yes, okay, but this is what I want to answer. How is oxygen circulated through the oceans?
From up to down?
Yes, from up to down. So we can see, maybe if people can see my cursor, for example, you have the current here. This is the Pacific Ocean. And the oxygen is mixed in. Well, no, sorry.
But how? I mean how?
Well, with the movement.
How mix?
Yeah, it mixes.
How mix between oxygen and water? It's different.
Yes, good. Could
different
someone?
state. This
Yes.
is liquid state and this is gas state.
Yes, good. Thank you. Could someone describe this? Hello, anyone? Yes? No? Okay. Well,
Yes.
Yes, go ahead, please.
There are some plants and the water, and the oxygen come in the plant, water. Some.
Okay. Sorry, I don't quite understand. But please keep trying. What do you want to say?
Planets. So you talk about the planets in the ocean.
Okay. Well, okay, so oxygen is in the atmosphere. It's in the air. But with waves and currents, the oxygen, the gas, gets dissolved into the water. That's why fish survive. They need oxygen that is dissolved in the water. So this happens at the surface.
Oh.
Okay, so there is oxygen mixed in the water, dissolved in the water at the surface. But the large global conveyor belt takes that oxygen and sends it down to the bottom of the ocean. So there is oxygen at the bottom of the ocean. But it's only because these currents are moving. If there were no currents, there would be no oxygen at the bottom of the ocean.
Life.
It's very important. Very, very important. Not only for heat, but for oxygen as well.
For life beneath the ocean.
Yeah, it's absolutely critical. It is so important. And unfortunately, with global warming, we can negatively affect the movement of this global conveyor belt. All right, and these global currents. And so I would like to go to Bill. Are you there?
Yes, I'm here.
Yes, hello, Bill. Could you please read this paragraph for us?
Okay. The global current conveyor belt includes both surface and deep ocean currents that circulate the globe in a 100-year circle.
1,000.
1,000-year circle.
No problem. Cycle.
Okay. Cycle. The global conveyor belt's circulation is the result of two simultaneous processes. Warm surface currents carrying less dense water away from the equator toward to the pole, and cold deep ocean currents carrying denser water away from the poles toward the equator. The ocean's global circulation system plays a key role in distributing heat and energy, regulating weather and climate, and cycling vital nutrients and gases. Gases, yes.
Great job. Okay, now that's the idea. Now let's see if I can pick something here. Let's watch this video, which is from Al Gore's presentation. He has been trying to warn people about the effects of climate change. So I'm going to put the YouTube link in the Verbling chat box, and I'm also going to play the video on the YouTube application. So I'm sorry, I'm going to stop here for a minute. I would just like to ask everyone, could you please keep your microphones turned off? And I would like to ask everyone, please do not click on the video, because you can control the video and you will send the video back or pause it or make it play again. So if we can just watch the video either with the Google Hangout, or you can watch the video by clicking on the link that's in the Verbling chat box. Okay, I was hoping that people could hear a little bit of that video. So what is the pump? What is the engine that starts the ocean water moving?
Sudden changes.
Sudden changes in what?
From water to ice.
Sorry, that's not really what happens in the ocean usually.
It's weather changing?
Adnan, not really the weather changing. No, sorry. We did read this in the paragraph, and I'm going to bring that up on the share screen, but do we have some other comments? Anyone?
Yes.
Yeah. What provides the energy that starts this water moving?
The difference between water density.
Yes, good. And so what changes the water's density, making it lighter or making it heavier?
Salt. Number one, the salty water. It's density, more density.
All right, it's denser.
Yeah, and the other, it's the cold water also.
Okay, good, right. And so primarily, I think it is the change in temperature.
So that's what I say now.
Yeah.
In the end of the video.
Yes, okay, but hold on. Adnan, could you?
Yeah.
Yes?
I said no, sudden changes in weather. So if the climate is changing, that's also mean that's the same now.
Well, no, but what we're talking about is the temperature of the ocean.
Yeah.
Okay, and so what happens to warm water?
This cold.
Down. Come down.
Okay, sorry. Warm water? What happens to warm water?
Come down.
Sorry, no.
Go up.
It goes up. What happens to cold water?
It's down.
Go down?
It goes down.
It goes down. Geoff.
Yes, okay. Well, and so what they're saying is these patterns of movement are just so important. And so this could be a terrible consequence of our climate change, where if this system of water moving gets stopped, it will change our climate very quickly and will also affect the levels of oxygen in the ocean and the movements of animals and nutrients. And so, good. We're going to stop the class, but great work, everybody.
Teacher, do you mean if
Thank you.
Do you mean if warm water goes down and cold water
Warm
goes
water
up? Weather will
goes up. Yeah.
goes. If you are saying the climate will change, the life will change.
I need to
Bye,
go.
Geoff.
I'm sorry. Thank you
Geoff,
so much.
Thank you.
Let's come to
It
my
was very
Facebook
interesting
page.
subject, Geoff.
Let's have another class about
Yes.
this.
Okay,
And you can come and we can practice discussing this. It's very interesting. Yeah, great. Thank you.
Okay.
Thank you.
Okay.
Thank you a lot.
Good work, everybody.